All right, we've got some great attendance here today for all of our folks joining from here in North America. Also, we're hosting this especially for our great supporters in Australia. So special hello to everyone down there. I've got one of my favorite Aussies presenting with me today. And without further ado, I think I'll just jump right into the introductions. My name is William Pryor. I'm one of the founding members of Skycatch here, and I work with our customers all over the world in implementing drone programs in various different verticals. Mining, construction, infrastructure is another one. And joining me today is Simon Jameson. So Simon is a licensed surveyor based in Australia. I met Simon through one of our customers, and we got to know each other working on a mine site in Queensland, Australia. Simon saw the power of what Skycatch could offer, and so he's actually joined our team and now runs our customer support organization for the Asia Pacific region. So welcome to Simon.
Yeah, hi everyone. Yes, Will said, my name's Simon Jamison. Customer Success Manager for the Asia Pacific region. Prior to joining Skycatch, worked as both a mine surveyor and a land surveyor up here in central Queensland, also Western Australia and down Victoria. Prior to joining Skycatch, I was working for Anglo American in an open cut mine, and basically came across the Skycatch because I could really see the huge benefits that it could offer people working in that environment, and basically wanted to share that with other people and get it out there.
Great, thanks, Simon. So between the two of us, we're going to cover a few different topics today. Just briefly, we'll look at this agenda. One covers, how the technology, how drone technology is typically introduced to mining team members. There's many different customers for mining data in mines, often collected by surveyors. And so Simon's going to walk us through how those consumers consume different types of data and what they're looking for. He's also going to speak about, we're also going to speak about the traditional mining workflow. And I think this actually gives us an opportunity to present an interesting comparison between what the state-of-the-art data collection method is today, which that would be, laser scanning, truck-mounted laser scanning and mining, versus a drone use case. And really, this is something that we're looking at. We have a system that functions kind of uniquely, and it's a great comparison for laser scanning and mining. There's a few different use cases in this, and again, I think what Skycatch has done in the past year is that we've created something that can really replace the laser scanner in mining. We're working with a number of customers who are doing exactly that, and so we can talk about those different use cases. Simon is an experienced pilot. He's one of our most experienced pilots, really, in the mining world. Is going to talk about tips and tricks for integrating this into your workflow. So, gotchas to look out for, things to be aware of as you're spinning up a drone program, if you have one already underway, or if you're planning one for your team. And then we'll kind of close it off with what we see as future vision for the industry. As you know, drones are a super fast evolving ecosystem. The way I put it, when we started the company here at Skycatch 7 years ago, you couldn't buy a drone, you had to build one. Now that you can buy drones, in your local electronics store, what we're really doing is providing an out-of-the-box data collection solution. So we'll cover that very fast-moving market. So again, speaking from the surveyor's perspective here, I'll turn it over to Simon, and Simon's going to kind of talk about the different teams that he looks at from a surveyor's perspective on who his customers are on these mine sites.
Yeah, so generally and from my past experience, when drone systems are introduced into the mining environment, it's generally the tech service department that's initially has the first touch, and that's generally through the survey department, because they're generally the guys who are gathering the data out in the field and stuff like that. So having a UAV system in place generally allows you to be able to gather more data more regularly and generally at a much better quality compared to other methods previously used. And this generally has a good snowball effect through the whole tech service department, with disciplines such as the short and term medium engineers, geologists and geotech engineers being able to make much better decisions with the superior and the more timely data supplied. For example, using a UAV system, you're able to capture a whole dig area in one flight. So that includes the material that's already been moved, say, for example, by a shovel, the current shovel dig face, and also what's happening up above the shovel. So where the area is being prepared for the shovel to dig through, so you're getting that optimal dig height and stuff like that. So that can all be captured in one flight, and basically, because it's all being captured via from the air, there's no missing data. So there's no holes, no gaps, no shadows, and that's able to give all the guys who are doing lots of planning and decision making the best kind of information to use. That then rolls down to departments like production and drill and blast. So again, these two departments really benefit from the data captured by UAVs to, again, help them with better planning. So because the engineers have better quality data, they're able to provide better dig plans for guys like the supervisors and the operators out in the pit. So that saves them on both time and resources. So you're generally just doing digs once, you're not going back and doing it 2 or 3 times. And also just the basic use of aerial photography from the UAVs for the use of presentation and things such as pre-starts and stuff like that. So that's one thing we really noticed, that they really want to incorporate as many aerial images into pre-start slides and stuff like that. So obviously pits can change rapidly over really short periods of time. So when people come to and from site, changing shifts, if they haven't been there for a week, it's changed vastly. So being able to get those aerial images, really showing them in detail how the mines change before they get out there, can be hugely beneficial for those guys. Another sort of terms of drill and blast, so it allows you to capture areas that you generally can't get to because there's heavy machinery working on it. For example, while drill preps are being done, there's lots of dozers and that sort of stuff moving around. It's really hard to get down on the ground and capture data. Because you can use a UAV system from a safe location, you're able to fly those areas, capture the data. You don't have to interact with any of that machinery, and then you can pass that information back to the drill and blast engineers, and they're able to constantly work on their plans and do what they can as it's progressing through. So they don't have to wait for the whole thing to be finished, and then if you'd be able to drive on there and do a pickup, you can give the information as it becomes available for them. And again, another thing for drill and blast, so a lot of time, if you want to capture large areas, say a whole drill pattern, rather than having to go around and capture holes individually, say with a GPS system or GNS system, you can do a flight of the whole area and capture that whole pattern in one go. So they can do a quick comparison to design and make sure it's all sitting in the right spot. So that turnaround of data is quite important to them. Another department that you generally don't think of too much is the safety department. So again, having a UAV system on site allows you to get access to areas that generally you can't or couldn't before that. So, and this allows you to better monitor things like the high walls and the low walls. So guys like your OCEs and stuff like that are constantly in charge of making sure everything's safe and correct, along with doing their drive rounds, can integrate a UAV into that system, and that allows them to get to areas that previously weren't accessible. Again, and also it can be used to help capture things like incidents and stuff like that. So obviously you can capture the direct area, but also allows you to capture a much larger area around the incident to possibly see what could have caused the incident, and then other areas that could be resolved, such as bunding height, grades of road, and things like that. So again, just another department that really benefits from that good quality information turned around in a quick time.
Thanks, Simon. Yeah, really interesting. I think there are many more use cases for 3D data on mining than I initially realized, more than just production survey. I just want to remind everybody who's attending that, first of all, you can ask a question at any time. We've got the question box over on the side. And also, we're interested to know if you're a data user on a mine that wouldn't fall into one of these departments, technical services, drill and blast, health and safety. Yeah, let us know maybe how you're using drones on the mine, using 3D data for your purposes. So yeah, feel free to kind of join in the conversation, and then we're going to bring up these questions during our Q&A session at the end of this at the end of the webinar here. So Simon, you talked about using a terrestrial scanner, as your sort of normal workflow. I was actually surprised sort of how common it was. That maybe over the past 15 years, terrestrial scanning on mines had really replaced standard sort of GPS, person on the ground type data. So, if you could maybe talk us through, your typical scanner workflow, which our listeners would be familiar with, and then compare that to, how drone data, had sort of changed that workflow for you.
Yeah, no worries. So this kind of is a good apples for apples comparison, I suppose, from an area that I personally surveyed. So we'll look at the terrestrial scanner one down the bottom. So normally when you need to scan an area, particularly a large one, you've kind of got to find particular locations where you can obviously set up and gather as much of that data with the scanner as possible. So sometimes that takes a little bit of recon work, driving around, a lot of interaction with plant, just to find those locations where you can actually physically see the area you're trying to capture with the scanner. So, I mean, just that part of it alone can sometimes take sort of around 10, 20 minutes, even more than that, depending on the size of the area. And then for this particular example, this was quite a large area, like nearly a whole strip in a coal mine, which was being prepared for drill prep. So basically, they wanted the whole area captured in one go. And this particular one took 10 plus scans from 10 locations, I should say, which took around the 1 to 2 hour mark, basically driving around to all these different areas, setting up, backsighting, scanning the location, and moving to the next one. So yeah, again, lots of interaction with heavy plant, lots of setups. Unfortunately, have to be set up on top of half up on buns and stuff like that. So just about to see down into this area to capture the data you needed. You then obviously have to travel back to the office and download the data. That can sort of take around the 30-minute mark, depending on where you're coming from site. Some sites are quite large, and that can be more than 30 minutes. And then once you're in the office, basically you can creating your control file, stitching all your scans together in a third-party software such as Point Studio, something like that. And then obviously making sure it's all fitting together. So that can be as simple as 15 minutes. It's all comes good, nice one go, or it's a bit of manipulation. You compare that to, we use the SkyCatch system to capture the exact same area. Basically, it was drive down, park up in a light vehicle park up area, completely bundled off from any heavy plant interaction, 10 minutes to set up the whole system. It was a 15 to 20 minute flight with one battery. Once it's landed, you can actually take the data from the drone and put that into our system called the Edge, and you can actually start the processing out there in the field. So basically, by the time you get back to the office, it's already been processed. You export the last file, bring that into your third-party software, complete a Q&A to make sure you're happy with the quality of data, and then you issue it out to whichever client has requested the data. For this example, the drill and blast engineers. So you can see quite clearly there's a massive difference between the two ways of gathering data in terms of safety, in terms of time, and also quality of the data. So basically, terrestrial scanner will generally always give you some shadows or missing data just due to line of sight, whereas a UAV is capturing all your data from directly above. So the only shadows you'll get is where a bit of plant could have been sitting there still for a period of time, which is minimal. So there's a huge difference in terms of the quality of the data coming from the two systems, for this example.
Yeah, thanks, Simon. And so this is interesting. This is a comparison between a terrestrial scanner and a no GCP UAV. Is that right?
That's correct. Yes.
And how much do you think the time difference would be if you had to actually go and set ground control, sort of for one of these data captures?
So I think it's probably very similar to having to drive around and find areas where you can firstly put the control marks where they'll be safe. Again, you've got that interaction with plant, and then you've also obviously got to coordinate each mark. So, and generally with a mine site, you can't leave marks around for days. They'll be disturbed by machinery and stuff like that. So if you are to use GCPs, it's normally every time you want to fly, you've either got to put down new marks or at least go and verify they're still there and still accurate. So that can be anywhere from your 20 minutes up to an hour, depending how large the area you want to do and how many marks you want to put down to get the best quality data.
Got it. So big difference in a drone that needs ground control points, one that doesn't need ground control points. And I think what I'm hearing is that you lose a lot of value in the safety benefit because even if you are using a drone, it may be a little easier. You're flying from off the site, but you still have to go down into the working area to set that ground control.
Exactly right. If you want to get that good data out at the end, you need to have those GCPs down in the area that you want to survey. So again, yeah, that generally means you have to go down there, interact with the plant. Whereas with no GCPs, you can fly from somewhere safe, like an LV parked up area, or even not even have to go down the pit at all and fly from a high wall, something like that. So yeah, the fact you don't have to put down the GCPs is a massive difference between the two.
Great, great. Now, I'm actually going to talk about a comparison that we did with one of our mining customers. This was actually in Western Australia, an iron ore mine, talking about that difference between a Skycatch drone system and another type of drone system that also actually doesn't use ground control points. So we're seeing that if you're thinking about using drone data, if you are using drone data and you're in mining, you've probably considered or probably are today using a high precision PPK or RTK system. So Simon just kind of covered that. From when you're going from scanning to using it, if you're not going to a node GCP system, you're losing a lot of the benefits in turnaround time and safety if you're still using a ground control point based system. So certainly to all of our listeners, who are in the industry, we recommend, again, a no GCP system really is the safest way to get accurate data, and often the quickest as well. Now, there are many types of different PPK system, RTK systems that are out there. Skycatch now has its second generation proprietary system called the Explore One that's on the market, and we're actually going to announce in this webinar today. We're going to talk about our support of the first DJI RTK-based system. But when we compare using other drone systems that use a high precision GPS to the Skycatch system, this is what we see. So a number of things have to happen after the flying in order to get good data out. So in the example here, this is a user that was comparing Skycatch use to the EB. So EB, very popular drone, comes with a PPK system. You can link it up to your base station. And when we look at the time use study that we did, comparing when the data is ready to go for your customers, we see that a big difference is there's a number of things happening simultaneously with the Skycatch system that are unique to us and our Edge One that are a little bit different than most other systems. So we'll go out into the field. On the left side here of the screen, you can see this is basically our setup, flying, and then driving and processing sort of time breakdown. So, a surveyor will drive from the office, enter the flying area, they'll set up and fly, land, and then, drive to the next site and start flying. When you have a system that, when you have a system that's not integrated, you're often using a number of different software systems in order to post-process the data. So in the example of the fixed wing, it was required to use some manufacturer-specific software to post-process the geotags. Then you'd bring those geotags into your, in this case, Trimble Business Center, and then at the end, after post-processing the data for high precision GPS, then you'd bring that information into a desktop processing app. Pix4D is pretty popular, and then crunch that on your desktop computer. Some people have dedicated computers for this, and I think at this site they actually called it the Bat Cave. So they'd go in the Bat Cave with this, desktop and do all their processing. Something that's unique with the Skycatch HPP, which stands for High Precision Package. The Skycatch High Precision Package is a drone and a base station that we'll show in just a second here. So it's an integrated base station and processing unit. When you're using the Skycatch High Precision Package, what the big difference in the timeline is, you can begin processing in the field immediately when you land. So the PPK processing and the photogrammetry processing are completed on your survey device. Your device that you take into the field, which is our Edge One, we'll show it in a second. It has basically a mini computer on board, and it's doing that PPK and photogrammetry processing for you. So this is a real-time use study that we did, kind of comparing other high precision systems. So again, just to be clear, neither of these systems are using ground control points. They're both zero ground control point solutions, and Skycatch is delivering the data, 3 to 4 times faster. Another advantage is, that only teaching users to have one software package, right? Where we're delivering point clouds, we're delivering 3D data directly to our users without the need for a lot of post-processing. So let's show you what that looks like here. The Skycatch Edge 1. Simon's been a big user of this. This has really caught on, I think, in the mining world, because it kind of turns the drone use, RPAS use paradigm on its head, right? What this is it's a GNSS base station, serves as a base station for both the Explorer 1 drone as well as the Phantom 4 RTK. So this GNSS base station will talk to a drone that has either PPK or RTK on board. And as soon as that drone lands, you can begin processing the data on this Edge 1. So what this means is there's no going back to the office to do PPK processing or photogrammetry processing. You don't need to upload anything to the internet in order to get your data back. And we are geopositioning specialists, right? We understand that it's hard often to get output data into your local coordinate system. We can accept localizations like calculations whether you're on an established grid like the AGD, or if you're on a local mine grid, we can use that too. No ground control points, exporting data right into your local coordinate system, like I said. If you're using drone data in mining and you're using a GCP-based system, you're really losing out on a lot of the safety benefits that come from a no ground control point system, right? Some of the big benefits that our users talk about are, reduced light vehicle, heavy vehicle interactions, and some other safety benefits that Simon's going to talk about in a moment here. Now, again, with a PPK system, RTK system, what kind of accuracy can we expect? We'll dive into that a little bit before, but we get proven accuracy better than 5 centimeters on most of our outputs. In mining, that typically will cut the muster. So that's something that we see that's both good for our civil and mining users. Now, when you need accurate data, right, and we take our survey customers very seriously, we know they need accurate data. We actually have an ability that's built into the Edge 1 to accept checkpoints. So if you've got any ground survey or any known points in the area that you've surveyed, we can actually input that into the Edge 1 and deliver an accuracy report as soon as that data is finished processing. And this is what that looks like. So, we'll take in a number of control points, process the data, and then we'll check your control points in your local system against the points in our 3D outputs, and then give you a processing report so that you know that the data has been completed appropriately. So this is kind of unique. Again, the Edge 1 is something that really gives us an opportunity to change the way drones are compared in the mining world. Again, when we look at what the Edge 1 does, it's really more similar to a laser scanning type of workflow. You go in the field, you use the device, and the device outputs a point cloud. There's no desktop computer required. There's no photogrammetry software required. It's really a new way of doing things. I'll touch briefly more on the sort of expected accuracy that we can get. Again, I think we have a lot of surveyors in the audience, and we want you to know that we take surveying accuracy very seriously. And this is what I mean. When you look at other drone companies that are releasing accuracy studies on the kind of performance they get, you'll often see a single data set maybe with a number of checkpoints in it. What they're missing is the statistical analysis that really drives a lot of surveying technology. You can see these figures in our accuracy white paper. You can go online and to check out our accuracy white paper. As you probably know, the height that you fly at will determine your ultimate output accuracy. In mining, you're typically flying higher. Maybe Simon, would you say that 100 mil, 10 centimeter vertical accuracy would be a good target for a mining user?
I think so, definitely. And when you're comparing it to a lot of mines will use LiDAR flyovers as their base, and that's about as good as you're going to get with that. So if you can be within that 100 mils, that's going to generally be more than good enough for anything you're chasing in an open cut mine.
Great. And on the safety side, what we're also seeing in mining is that because there's large changes in elevation, you want to be flying at a higher altitude. So At 100 meters, Skycatch is typically hitting about 7 centimeters or 0.2 of a foot on our vertical accuracy. Definitely passes muster in mining. If you're more civil focused, if you really want those tighter tolerances, all you got to do is fly a little lower, improve the resolution or the ground sampling distance of the outputs, the GSD, and we can sneak in there all the way down to, just under 1/10 of a foot, or maybe 2.5 centimeters, as you can see here. So this is again, we have accuracy outputs that are really in line with LiDAR. And then we finally have a product that competes with scanners as far as take it to the field, use it, and output a point cloud. No post-processing required. Simon, maybe you can talk about the different kind of deliverables that the Edge One can output, and what the different things are used for, in different contexts. I think with your experience as a mining and a civil surveyor, you can probably speak to most of these.
Yeah, so obviously you can see there on the left-hand side, there's a lot of different deliverables, such as a TIFF, your basic DXF contours, an object file, which is a 3D mesh, a last point cloud, digital elevation model, a simple orthomosaic photo, the 3D mesh, and the digital service model with or without ground return. So generally, from my past experience, most people in the mining environment will generally just want the point cloud. They'll bring that in, create a surface from it, compare it to existing data, and that's basically all you'll need. Whereas a lot of other people, suppose in the civil or construction, generally really like the use of an updated orthomosaic photo on a regular basis. They can fly sites daily, twice daily, constantly know where everything is on site. Something like a basic DXF of contours is really good for guys who don't have really powerful processing software. So if you've just basically got vanilla AutoCAD or something like that, you're able to get just contour lines in DXF format and bring those in. And again, you've got your TIFF photo, which is geo-referenced. So again, you can bring that in as an overlay, dump it straight over your actual survey data, and just do some nice comparisons there. So as it says, there's many different outputs, and that kind of suits everyone's different needs. So depending on what industry or what you're trying to achieve, there'll generally be an output there for you and what you want. So which is really, really good.
Yeah, thanks, Simon. And I guess I have a question. So, the Edge One, we do have a object removal feature that's built in, or as we call ground return. So you can see it here. We're stripping out a few buildings, some cars, some vegetation, getting down to that bare earth surface. In the mining world, was this something that you use, or did you typically do, manual sort of trimming of these point clouds when you're creating your updated surface?
Look, to be honest, probably most of it was done manually. Generally, like obviously an open cut mine, there's generally not that much stuff on the surface you're trying to capture. Maybe a drag line, maybe a couple of dodes and stuff like that. So generally, it was easier just to quickly, in the software you program using, such as a Point Studio, just manually cropping those out. But I do know from speaking to people who use it more in an environment like this, where there's more vegetation, buildings, stuff like that, having this option to do it automatically for you saves them so much time and hassle. So again, it really depends on what environment you're working in. So, but even then, if you're working in an area, say in a mine that's half rehabilitated and there is existing vegetation, being able to apply this algorithm automatically and not having to remove that stuff yourself is a massive time saver.
Definitely, thank you. So again, this is we've got some, Simon, you have all the experience in sort of working around these heavy vehicles. Maybe you can talk about how the site that you worked at looked at drones from a risk reduction perspective.
Yep. So basically, coming from a survey background, probably the most dangerous thing in your day-to-day operation was just the light vehicle interaction with the heavy vehicle. So basically, you always had to be driving defensively. Obviously, you may have had right away, but you couldn't guarantee the truck could see you at all times, gave very poor visibility and stuff like that. So in terms of making sure you got home at the end of the day, for me, it was always the biggest issue, or biggest safety issue, was heavy vehicle interaction. So basically, if I could minimize that in any way, in terms of not having to drive down in the pit to capture data, if I could capture any other method, I would obviously always do that. So that was probably the biggest thing in terms of being able to use something like a UAV system to be able to capture the data from a safe area was kind of a no-brainer for myself. And again, something that, as you said, mines in general look really well on. I suppose for every mine, safety is their #1 priority. So if everyone comes home at the end of the day, that's a tick, and that's what they want. So and just another basic thing is, you can see from the picture there, not having to walk up and down things like stockpiles on top of buns and stuff like that. Again, they might not be fatal errors or fatal things coming from it, but still a fall or a sprained ankle or a grazed arm and stuff like that, they're all incidents. So if you can minimize putting yourself in any sort of danger, it's always going to be look positively on by mines and mine operators.
That's great. Thanks, Simon. And one other thing kind of interesting when you mentioned the light vehicle, heavy vehicle interaction is that some of our customers, for example, are operating autonomous trucks on mines, quite common in Australia and beginning in other parts of the world as well. If you're somebody who's advocating for a drone program on your job site, an interesting value prop that we see is actually you get higher per shift haul rates when you're using a drone system, like especially a no GCP drone system, because with these reduced light vehicle, heavy vehicle interactions, the trucks have fewer interactions with light vehicles. They slow down less. They maintain higher haul speeds. And when you're working in a mines that are really tremendous scale, often if you're looking for an ROI, that ROI value prop can come from extra tons hauled per shift, just because these trucks are having fewer interactions with those with those light vehicles. And then I guess my last question for you, Simon, is so did you, once you switched from climbing up and down the various areas of the mine, and you switched over to the SkyCatch system, did you gain any weight from the reduced walking around that you did?
No, luckily not. But just to recap what you were saying about the interaction with the trucks, that also goes with other bits of machinery, such as your drag lines and your shovels. So basically, anytime you had to stop any bit of machinery to capture any sort of data, that was a breakdown in production. So being able to do that without having to stop any of that sort of machinery is a massive selling point to the production side of things.
Yeah, and a big impact on the bottom line.
Definitely.
So what we're going to do next here is play a video showing some interesting things that we've built here at SkyCatch to sort of enable more use cases with drone data. To date, I think a lot of what we've been talking about has been that production survey, topo mapping, really focused on the planning departments. With one of our clients this year, and actually a few of our clients, we've deployed a high wall mapping solution to our customers to really target, I think, one of the two main groups that are data consumers in the mine. And I think that that Simon, for example, you would deliver data to these two groups. So one is again, that sort of traditional top down point cloud delivering production rates, topo map essentially. Another, and then that's something that a lot of our customers are wanting to replace scanners with drone data for that purpose. There's another use case that scanners are used for, which is this high wall mapping. So what I'm showing here is a proprietary technology that SkyCatch has developed in the past year, where we're leveraging our high precision system along with a secondary camera to do very detailed mapping of high walls for facet detection for geotechnical use cases. So this is, again, helps us drive at that comparison to say, hey, how can we actually remove laser scanners from the mining workflow and replace this entirely with drone scanning? How can we achieve that super high density that's necessary to actually achieve that use case? There's a few things that we had to develop in order to do that. One was terrain following. So what you can see here is that we have our drone flight path that's actually dipping down into this open cut, and then scanning the high wall off to the left, and then modeling that high wall in very high resolution for the end user. Again, no ground control points needed, super high resolution outputs, and something that's really unique. A number of customers are very excited about bringing this capability on board. And this, in a sense, closes the loop around what you know, again, what those different things that the scanners are used for. I think if we say, oh, we're just replacing the topo survey, we're only getting halfway into the value of the scanner, right? Once we start doing this high wall mapping as well, again, no GCPs required. You get full colorized outputs, high density mesh, you know, things that the geotechs can use and do their rock face analysis. Now we're actually considering, okay, we can completely replace these scanners. And I think maybe on the site that you were at, Simon, you know, that was one of the use cases. I think they were able to really go from, you know, almost using the scanner for just about all the survey tasks to, you know, in the course of about 6 months, going to using the drone for just about everything.
Yeah, that's correct, Will. And for this example here, I know that a lot of areas, for example, once the coal's mined out, the areas can be just blocked off for access. So sometimes actually being able to get into these areas and scan these higher walls is quite hard and can't be achieved. So having this system here allows you again to get into areas that sometimes previously couldn't. So for example, this one here, we are able to scan that whole higher wall using the Skycatch system without actually needing to physically get down there in that pit. So it's a massive advantage. So in terms of that compared to a traditional scanner.
Now, here we're showing something that's a little bit of a bigger area. You know, we're different users, different data customers are going to have different use cases. Maybe you could hit the main use cases, Simon, for the main use cases for this high wall mapping.
Yeah, so from my previous experience, probably the two main users of the high wall data are your geologists and also your geotech engineers. Basically, we did a scan and provided the data to the geologists, and they just couldn't believe the amount of detail they were able to see within the high wall, such as how the coal seams were moving and dipping up and down, and just overall the amount of detail they were able to see. So obviously, yeah, the geologists can just see all the different types of rocks, what the coal seams are doing and stuff like that. And then your geotech engineers are able to actually analyze the integrity of the high walls and those sort of things, check for fractures and all the things that they need to be able to check for to ensure the integrity of the high walls there. And that also goes for the low walls too, for an open cut coal mine, which is very important, making sure the integrity of those are in place.
Got it. So yeah, I think different use cases, both you can make the geologists and the geotechs happy. They're looking at different things, but ultimately one system that can really do it all.
Yeah, that's exactly right, Will.
Now, if you want to take it here, I think, you know, you had the experience of being on a site that had trialed a few UAVs, but really kind of, you know, once we started working together, kind of spinning up a lot more use. So why don't you talk a little bit about what you've seen kind of in your experience of you know, UAV RPAS best practices?
Yeah, no worries. So basically, prior to getting the Skycatch system on board, we sort of did a bit of a trial just using your DJI Phantom 4 with the use of GCPs, kind of just covering large areas like your rehabilitation areas and stuff like that, which are really hard to capture with a scanner. So, I mean, it served the purpose. We're able to capture the data, but as you spoke about, Will, the processing time after capturing the data is quite extensive, and it's not a quick turnaround time. So that was probably where we started, and then obviously moved to the Skycatch system, which changed things dramatically. In terms of best practices, I think with a lot of open cut mine sites, you can use it under the rule of the landowner exemption rule. So you don't need to actually get your license and stuff like that to operate a drone. But I found from experience that it's always best to get that appropriate training qualification. So because it just gives you the competence to operate the UAV safely and correctly. And I suppose, like any bit of technology, sometimes things can go wrong no matter what type of UAV it is. And being able to know what to do in those cases is really good. So, and that kind of leads into the maintenance and pre-flight checks of both the drones. So basically, again, like any piece of mine equipment, you've got to ensure that it's working correctly and that appropriate safety checks are in place. So things such as batteries are a really important component of a drone system. So making sure that batteries are correctly maintained and stuff like that. And again, just the drone is maintained correctly. So having those two things in place is probably the first step to operating a UAV correctly. If either of these two things aren't done, then that's probably going to lead to issues down the track eventually. So again, as I said, probably the first two things you want to tick off. appropriate training, and then also make sure you've got that maintenance and those free flight checks in place to make sure that you can have safe missions all day, every day without too much issue. Another thing I recommend is just learning to crawl before you run. A lot of times people get a UAV system on board and they'll just want to be able to just do everything with it. So jump straight into end of month and stuff like that, and really time critical things. And if things do go wrong, can really have a negative effect and can leave a bit of a bad taste in your mouth. So I mean, I recommend if you're starting a system on your site, just start with trial areas, less critical areas like your big rehab areas that, again, the turnaround time's not super critical. You've got time to work out any issues that you might be having. Build up that confidence level, start implementing it into your production work, and then really start using it to get the maximum benefit for things like end of month and stuff like that. So a lot of sites will use a traditional LiDAR pickup on a monthly basis to complete their end of month. But having a system like Skycatch in place allows you to capture really good quality data of big areas. So you can do all of those volumes before you get that data. So if you know an area has been completed, you can go and capture it. You know the integrity of the data is good. You can use that for your volume calculations. And then basically when you get that flyover data, you can just do a quick Q&A and make sure you haven't missed any areas, and you can just get ahead of the ball. So I think that's really important. Just get confidence in using the system before you dive in too deep and just try to do everything with it. And again, I suppose that kind of leads to my last point, is just, again, making sure you're using the right tool for the job. As a surveyor and a person in an open cut mine, like UAVs can obviously gather huge amounts of data in a really short period of time, but sometimes it can just be overkill. So don't just expect it just to do everything for you, because sometimes it might not be the best tool. We still would use a GPS system on our cars just to do basic drill prep pickups. You drove the perimeter, got a few spot height checks out, and that was the best tool for that job. And in cases where you couldn't get to that area for some reason, then yeah, you'd use the UAV. But again, I think it's just making sure that they're used in the correct way and for the correct job to really get the maximum benefit out of them. So that's probably the main things I suggest when you first start using a drone on site.
Yeah, that's great, Simon. I think very wise to say too. If I can think of all of our customers, those who really hit the fundamentals first and they hit those sort of main value props, first, without thinking that they're going to, completely automate their site like in a month, are the happiest customers that we see, right? It's sort of like get good at level 1 before you move on to level 2. And then the second, using the right tool for the job, I don't think we're doing anybody any service by overselling what we can do. We're really focused, especially on this, for the purposes of this presentation, on, how we're replacing laser scanning and mining survey. We did get a question that came in, whether the Edge 1 can be used with a multispectral camera. So today we don't have multispectral support on the Edge 1. This question is from Jacob Draper. So I'm actually, feel free to email me. I'm interested in learning a little bit more about how you want to use multispectral. We don't process multispectral on the Edge right now. But there was another part of this question: can it be used without RTK or PPK? And the short answer is yes. During 2020, we'll be releasing a sort of no PPK functionality, needed to process on the Edge. So yeah, go back to using the right tool for the job. There's a lot of things that we can do, I think, really well, and that's definitely our focus for the mining sector. So another question that came in was. The other question that came in was, what is the HPP, right? So I think something that Skycatch has always done is we think of this, data collection solution as something that's really integrated. I said it at the beginning of the presentation. When we started the company, you couldn't buy a drone; you had to make one. Well, nowadays, and then a few manufacturers came along, and now you can buy drones at your local electronics shop or hobby store. What we've done is we've assembled everything that you need to have a real data collection package. So that's our high precision package. You can see here we've got our Explorer 1 on the left, and we also support the DJI Phantom 4 RTK. So if you're a user of that system, definitely reach out to us. We'll make sure that you never have to sit in front of a desktop computer crunching data ever again. And we do manage better accuracy than anybody on the market as far as using this system. So that's something that we're really excited to be getting in customers' hands. It's not a piecemeal solution. There's no bolt on this or click this wire together. Again, no ground control points needed. We have an integrated cloud solution that actually comes as an add-on. So if you're just a mining surveyor, you can use that Edge One to turn data around really quickly. Some of our folks on the civil side, they prefer to, they're really all about sharing the data. They can share that data online, and so you can sort of do this, one or the other or both as you wish. And then just sort of as a last item, we've really always been accuracy focused. We are accuracy focused from the ground up, and it's we have a number of surveyors. Simon is one of them, but we have a number of surveyors on our team who really keep us honest and can speak to the special power of the system. So that's Skycatch in a nutshell. One manufacturer, global support, and a truly integrated product. So, I said that we would just take a brief look at, kind of what's happening in the future. And the first point I want to make is that I think, early on, people thought that drones would just replace, aerial flyovers, right? So anything like, again, I think mining and construction, they both do this. They get aerial flyovers to track progress. And if I'll say, if all you're doing is replacing a traditional aerial survey with a drone survey, you're leaving a lot of value on the table, right? You're definitely doing it in a cheaper way, but the ease of use of drones, the ability to be able to deploy them, out of a box, out of the back of your ute, in no time, being able to process data in an unlimited fashion. That's with our Edge One or our online processing. There's really so much more that you can do. The more that you utilize drones, the more that you can kind of establish new use cases. I think if we were just looking at trying to replace, costly aerial flyovers with drone data, we never would have realized that this is actually a viable replacement for truck-mounted laser scanning. But now, because we made something that's easy to deploy, roll up into the field, take it out of the box, and fly, it's something that is really hitting a value in a different way. So I'll summarize this by saying the more you use the drones, you can discover new ways to sort of get value out of them, and that especially applies to our mining and construction customers, who are doing more scanning than ever. Another item here, we're seeing, especially in the mining industry, right, greater automation. So, some of the goals of our strategic customers are aligned with, bringing greater automation onto mine sites. And honestly, the best companion to a robot is another robot. We by eliminating those sort of human-machine interaction. Again, we're really improving safety and increasing simplicity of the system. So some of these automated systems are not as good at handling, the X factor of, okay, what if, someone cuts in front of me at, driving 20 miles an hour, they'll go into some emergency braking mode. Again, by taking people out of the pit, by eliminating the need for ground control points, and then delivering data super fast, that's definitely something that we see these drones, these robotic systems, having a big impact in mining. And then Simon, why don't you wrap it up? You can talk about sort of what the live model and what the fully digitized site means to the mining industry.
Yeah, so I suppose a lot of mine sites now sort of work on a static model. So basically, plans are issued at certain periods of time. Whereas I think going forward, most sites will be looking at having live models. So basically, lots of machinery such as your trucks, your dozers, shovels, drag lines, all that sort of stuff, they've all got GNS systems on them, plus data capturing devices. So they can all be fed into a live GIS system. And then with that, you can also feed in data from your UAV system like a Skycatch. So as I said, rather than people having to use static models that could be outdated, people have access to a live model. It's constantly changing, constantly evolving, and constantly up to date. So I think that's the way of the future, I guess. So again, so everyone always has the most up-to-date data available. So again, they can make the most accurate and best decisions at that time and aren't using that outdated data.
And you know what that really reminds me of is the sort of modern practices that are put into place in things like, you know, just-in-time manufacturing, very data-based decision-making systems. You know, we're seeing things like construction, things like mining, adopting these, you know, digitalization programs so that they can manage, you know, what's happening on the mine site just like they would manage what's happening on a factory floor or a sort of much more quantified environment. So, you know, if you're someone who's looking to grow that drone program, you know, on your mine site, you know, you can speak to that management desire to you know, use a more data-based management method. And the more data that you have, you know, the better you can manage these systems. So definitely echoing what Simon said there. So we'll do a quick Q&A. We had a few questions come in. I tried to hit those. I hit some of those kind of as they came in, but I'll do a couple here now. We had one, and feel free to add some more. We do have just a few minutes left before the top of the hour. So someone asked, what about flight-to-flight difference detection for near auto high wall deformation or failure info? So, you know, this is very interesting, and I think this touches on what I was talking about before. You know, don't try to replace your monthly flyovers with a drone. Try to replace your daily activities with a drone, right? And when you have a high precision system, you're getting 3D outputs on a constant basis. So, you know, I think you know, we are releasing this year a online system, browser-based system, which will be able to take files in from the Edge One and compare them, you know, very easily on, you know, tool that's meant for this kind of difference detection. It would be similar to like a cut and fill tool in a civil program. So I think yeah, stay tuned in 2020 for this. It's gonna happen on our web platform first, and then we're gonna bring this down into the Edge One. But you know, great question, right? I think quantifying change in the environment is all of what we're about. And then we got another question. Will it work with the Inspire One? So yeah, good question. We don't have direct support for the Inspire One now, but I'll say, you know, again, stay tuned in 2020. The Phantom 4 RTK is the first, you know, DJI standard drone that we'll be supporting. If you're interested, we have an early release program right now, so you can reach out to our sales team, sales@skycatch.com, to if you are a Phantom 4 RTK owner. For the Inspire One later on this year, you know, feel free to get in touch with us, and you know, you can get more solid timelines on this. But we do want to support, you know, drones that are more maybe a little more traditional, that don't have high precision GPS. We certainly care about those, but we're targeting those high precision drones first. Another question, you know, what are the future plans to deliver higher accuracy? You know, great question. Sensors are always improving. If we look at the accuracy evaluation that I showed earlier, you know, the interesting thing is as you fly lower, really what's happening is you're getting a smaller pixel size on the ground, right? So higher resolution cameras are really, I think, the main thing that's going to drive this in the photogrammetry world. That's something that we're always exploring is higher resolution cameras. And I also think that you know, when you say what are our future plans to deliver higher accuracy, we want to make it easier to get high accuracy. So some other things that we're thinking about is making it easier to use these edge devices on a mine site. Right now, the edges can self-position if you're on an RTK network, but we want to, you know, maybe you know, bring something in that's having these edges talk to a more traditional base rover setup that's on a mine site, so that we can talk to your base. Last question here, is there an option to manually edit the image matching point cloud process should the autonomous outputs go wrong? Good question, and short answer is no. We build the system for you know, super ease of use. We can typically train somebody on creating good data in about an hour. It's a little different than something like a Pix4D where you have a lot of editing options. That is a reason why we focus on high precision systems. If you're a user of you know, a desktop photogrammetry software, you may know that these you know, photogrammetry matching is actually significantly improved by having like a PPK or RTK system. So So short answer, no manual editing, although that really hasn't been a big complaint from our users. We have thousands of data sets being processed on the edge every week, and those are not the typical types of failures that we see. So good question. Let's see, last one. What's the difference between using the Phantom 4 and your DJI drones? That's the Explore one. Couple differences. I think really it boils down to your focus and also supply chain. The great advantage of using the Phantom 4 RTK is that you can supply one from a retailer in your area, and then license our Edge one and use it along with that. The Explore One drone is a bit bigger. It handles the wind a little bit better, and it's got a lot of time, basically proven being used high altitude, low temperature, high temperature, things like that. So I think a little more ruggedized, a little bit better at capturing big areas. But we're really excited to release this Phantom 4. We're really excited to release this Phantom 4 compatibility, in this coming few months. So again, if you are a Phantom 4 RTK user, reach out to us. We'd love to talk about making sure that you'll have faster outputs than ever, more accurate outputs than ever. We've been doing thousands of flights with the Phantom 4 RTK, and we're getting great results, and we want to bring this out into the market. So I think that's just about all that we have time for now. A couple of questions there that still remaining, which I'll follow up directly on. But I just want to say, you joined. We appreciate you taking the time out of your day to listen to us, chat about drone data. Simon, if you want to send it off for us.
Yeah, I'll just echo your thoughts, Will. Yeah, thank you everyone for joining. It's been a pleasure to present this to you. And if you've got any questions, please reach out to us, and we'll get back to you.
Great, thanks. And we have our contact details up on the screen here if you want to reach out. Sales@skycatch.com, or you can just go to our website and chat with us directly there.